Hello everyone, I'm Xuelin from Fudan University. It's a pleasure to share our recent work entitled Exploring Implicit Fields for 3D Object Detection. For this task, it takes point clouds as input and outputs boxes for objects. A general way to represent the boxes is with several parameters, that is localization, dimension, and orientation. Despite its popularity and universality, such a paradigm is insensitive to slight numerical deviations, especially in localization. Inspired by implicit fields in 3D modeling, which assigns a value to each point and extracts meshes with isosurface. We advocate an explicit way to build bounding boxes by classifying internal and external points. However, assigning values to all points for each potential object is burdensome, and because of distance and occlusion, point clouds of some objects are sparse and incomplete. Both challenges make the application of implicit fields inefficient and inaccurate. To this end, we propose a novel framework named ImpDet. First, it uses a backbone network to extract bird's-eye view features. Taking a pixel as an example, we then shift its location toward the potential object centers as content center, so that the implicit fields can be performed on a local 3D space rather than the entire one. Assuming we have searched neighbor point clouds in local space, here we also show bird's eye view for better understanding. To tackle the problem of sparsity and occlusion, we uniform place virtual points around the candidate center. A dynamic convolution is performed to produce parameters of implicit function to adaptively assign values to classify internal and external points. We thus fit a series of minimal boundaries with different orientations. The optimal one is selected with a minimal accumulation of point to surface distance. Our proposed implicit boundary generation can provide high-quality boxes without any predefined anchor, but for evaluation, it lacks the classification score and the accurate orientation, which should range from 0 to 2 pi. So for the last stage, we adopt our grid pooling to make up these features and refine the boxes. We further improve it by reducing the implicit values to enhance the features of internal points and suppress the effect from external points. In the following slides, I'm going to show some experimental results. We first compare with several state-of-art competitors on KITTI data site, showing the efficacy of our model. We also report results on other categories such as pedestrian and cyclist. Vehicle detection results on Waymo validation split further supports the above conclusions. To prove our motivation, we provide the impact analysis of randomly shifting box centers or masking internal points. It shows that our ImpDet is more robust to these numerical deviations. Lastly, we also show some predicted results for visualizations. That's all. Thank you for listening. You can find more details in our paper and be free to contact with us for any questions.